Hi, my name is Linesh Murugan and my matrix card number is 01DEE25F1009.
Hi everyone, my name is Abhimanyu, son of Nandan. My matrix card number is 01DEE25F1019.
Hi, my name is Vishal Ratnam. My matric number is 01DE25F1021.
Good evening everyone, my name is Karthikeyan Agrivan and my matric card number is 01DE25F100.
Now I am going to be talking about introduction of differentiation. Differentiation is a technique to use to calculate the gradient, stationary points, maximum and minimum points of particular function. For example, we use differentiation to calculate cost, strength, amount of material used in building, profit and also loss. Differentiation is met in many engineering and science problems, especially when modeling the behavior of moving objects. Thank you. Now we're going to talk about increasing and decreasing function. The derivative of a function may be used to determine whether the function is increasing or decreasing on any intervals in the domain. If fx more than 0 at each point in an interval, the function is said to be increasing. If fx lesser than 0 at each point in interval, then the function is said to be decreasing. Because the derivative is 0 or does not exist, only at critical points of function it must be positive or negative, all other points where the function exists.
Stationary point. In mathematics, particularly in calculus, a stationary point of a differentiable function of one variable is a point on the graph of the function where the function's derivative is 0. Informally, it is a point where the function stops increasing and decreasing. Stationary points are easy to visualize on the graph of function of one variable. They correspond to the points on the graph where the tangent is horizontal, which is parallel to the x-axis. For function of two variables, they correspond to the points on the graph where the tangent plane is parallel to the xy axis. To determine the stationary point is a maximum, a minimum or a point of inflection, we must apply the second order derivative. Maximum, minimum or point of inflection. At all stationary points, the gradient is the same, equals to 0, but it is often necessary to know whether you have found a maximum point or minimum point or a point of inflection. Therefore, the gradient at either side of the stationary point need to be looked at the second derivative. At maximum points, the gradient is positive just before the maximum. It is 0 at maximum and it is negative just after the maximum. At minimum points, the gradient is negative 0 then positive. Finally, at point of inflection, the gradient can be positive 0 or negative 0.
Hello everyone, so today we'll be discussing about example question for stationary point. The question that I have stated is find the stationary point on the curve y equals to x squared plus 10x plus 30 and determine what type the stationary point is. So now let's solve this question. Y equals to x squared plus 10x plus 30. Therefore, dy over dx equals to 2x plus 10. How did we get 2x plus 10? We used the x squared times to the forward number and we'll get 2x. Same goes to 10x. The x does not have any power, therefore the x is removed. And the number 30 does not have x, therefore the whole number is removed. So now let's go to the stationary point. dy over dx is equivalent to 0. So 2x plus 10 equals to 0. 2x equals to negative 10. X equals to negative 10 over 2. And x equals to negative 5. Y equals to x squared plus 10x plus 30. Substitute the x value into this equation and y is equivalent to 5. Therefore, the stationary point is negative 5 and 5. Now, let's go to the side part where it is dy over dx equals to 2x plus 10. So, d square y over dx square equals to 2 is greater than 0. Therefore, this is the minimum point. Thank you. Now let's move on to example question for rate of change. As you can see, we have a question here. Figure 1 shows a metal cube which is expanding uniformly as it is heated. At time t seconds, the length of each edge of the cube is x centimeter and the volume of the cube is v centimeter cube. Now there are three questions that is asked here. 1. A. Show that dv over dx equals to 3x squared. Given that the volume v centimeter cube increases at a constant rate of 0.048 centimeter cube per second. B. The second question. Find dx over dt when x equals to 8. Now in this question they already given us the value of x, which is 8. Now question number 3, C. Find the rate of increase of the total surface area of the cube in centimeter square per second when x equals to 8. And in this question also, they have already provided us with the x value, which is 8. Now let's solve this. A. Show that dv over dx equals to 3x squared. So how did we get the 3x squared? So therefore, v equals to x cubed. Therefore, dv over dx equals to 3x squared. Because x to the power of 3, you times the 3 to the whole number in the forward, so it becomes 3x, and you minus the 3 with 1 because you have already times it in the forward number. Therefore, it becomes 2. So the dv over dx equals to 3x over square. Now let's go to the B question. In the B question, they have already given us the volume V equals to centimeter cube increases at a constant rate of 0.048 centimeter cube per second. Now this is our crucial points. Therefore, when they have said that constant rate of the increase of constant rate, they already given us that 0.048 centimeter that we can consider as dv over dt. Now let's find dx over dt when x equals to 8. Since they have already given the value of x, which is 8, we can substitute them in the forwarding solution. So dx over dt times dx over dv equals to dv over dt equals to 1 over 3x square times the constant, which is 0.048 times 0.016 over x square. Now that since they have given the value of x, we have to just substitute them into all the x value that is unknown here. So when x equals to 8, dx over dt equals to 0.016 over 8 square equals to 0.00025 centimeter square per 25 centimeter per second. Okay. Now let's go to the third and last question, which is find the rate of increase of the total surface area of the cube in centimeter square per second when x equals.
Okay, so in conclusion, with the help from the previous slide, we can acknowledge that differential is used in almost everything. With the use of differential equipment like odometer and speedometer can be improved. So differential is used to find change of one thing with respect to other. So differential can help to make tomorrow better.